Hello, folks. Today is April 11th, 2018. This is the kubeadm office hours, and we have a couple of items to discuss. The first one is to try and give a TLDR update on the state of the upgrade issues. I know there's two parts to this. One is the configuration file part, and the other is the ordering of restarts because of the cert modifications that were done in 1.10. Jason, you want to give a quick update of the state, and Lee, feel free to chime in on any questions, comments, complaint, concerns.
The PR to fix the race condition on checking pod status is ready to go. It's just pending an additional PR that unbreaks the upgrade. Speaking of which, I've started work on a PR for using the kubelet API for checking the pod status, and then further using the etcd client to check the etcd pod status specifically, because one thing that I found when using the kubelet API versus checking on the mirror pod, the kubelet API shows the pod changed as soon as it picks up the new static manifest, and it does not update pod status on the pod's endpoint for the kubelet. So we have no way of testing to make sure that the new pod is actually up and running unless we query containers, and that gets into some of the issues around querying the CRI or mucking with the stats endpoint for the kubelet. So to avoid that, I just went ahead and attempted to use the etcd client to verify that we at least get an etcd status back after it picks up that manifest change.
And quick question.
Yep.
When I was reading through the specs for this, liveness probes are not implemented on the static pod, right? Or no, they are, but then do they not show up in the pod's endpoint?
So the kubelet pod's endpoint doesn't seem to show any type of pod status for the static pods. It shows that it was requested to be run, but it doesn't show any update as far as running.
But that only shows up on the mirror pods then?
Yep.
Okay.
Exactly. And you don't see the mirror pods on the kubelet endpoint.
So this isn't something that we talked about when we had our pairing hour, but this seems to be probably the most major deficiency of using the kubelet API versus the mirror pod API then.
Right. So the way that I've handled that, for etcd, I just go ahead and query the etcd status.
Yeah.
And that does the trick.
You just do your own liveness probe, basically.
But what I'm doing with the other static pods is I'm waiting for the update on the static pod with kubelet API, and then I'm also waiting for the mirror pod update to come through to verify that the pod has been deployed. It's not ideal, but it seems to get the job done.
I think we need to comment and isolate the heck out of this because ideally the kubelet API should be able to give you a liveness check. The kubelet API is sorely ill-maintained, right? It's not something that is a first-class thing that people leverage all the time. It's kind of hidden underneath the hood. So we need to talk with the SIG node folks about that too as well. And the reason why I say that is because it's subject to change, and it has changed and drifted and been moved. So how we're going to do the upgrade testing is going to be super important, right? As we get into the next release cycle, I've mentioned setting up a test apparatus, and as well as the CNCF folks came around, but there's no good way of testing this without it being like a true end-to-end type of test.
We do have an action item on the because I joined the retro call for the release.
Yep.
So the release group is aware that that during this cycle that we're going to need to get some blocking tests in for the upgrades.
So it's a conundrum though, because no one wants to maintain, somebody's going to have to pay the tech debt to at least patch how Kubernetes Anywhere upgrade path works. So I know the problem. I know why it's doing what it's doing, and I know why it's out of date. I suppose we could probably fall on the sword there, but it's kind of like we're just going to go in there and try to band-aid it so we can get past this point. So the way the upgrade tests originally had worked is Lucas kind of baked in some suppositions about where things would be published for cross-build products. And he did that to ensure that like you had the cross-build products as part of the output results for the upgrades, right? It was kind of like, it was a conflation of concerns for sure, but it forced checking of multiple things within one suite, right? So it basically validated that we are actually publishing the cross-build products as well as consuming the cross-build products as part of the upgrade tests. And we can eliminate the cross-build product issue because it was not actually working. We weren't actually publishing them. So if you actually look at some of there's multiple pieces of output that is put there. And one of the build artifacts to push some of the cross-build products no longer was even working. So I guess I'm going to be full-time on this stuff, so I'll fall on the sword there. I feel like if we don't do this, we'll be in this problem again. And I ideally wanted to have cluster API in place so we could just kind of get convergence in the long term, but I don't think that's going to happen within the 1.11 cycle. Is that a fair thing to say? Because nothing's going to go into the test apparatus unless it's beta. All right, so why don't we put an action item for me then here? Okay. Is there anything else to mention about that? Is there?
Yeah, I think we cut Jason as first point, but he's probably going to also talk about not starting on the ensure TLS phase yet.
Yeah, I haven't started on those changes yet because I'm not familiar enough with kubeadm to understand exactly how all the phases work out right now.
So I looked at this, and 2 weeks ago, I brought this up, and Tim had some comments about, or Luke and Ilya on the SIG call had some comments about refactoring, because it's a little rigid right now about what is in scope. So, for instance, you do not have kubeadm config in a lot of the upgrade functions, and it gets a little tricky. Basically, some code needs to be restructured. But as far as adding an ensure TLS phase for these static pods, we should be able to just add a phase for upgrade or under upgrade in the CLI, and then call it directly as well from the upgrade path. So from the main function. So it should be callable independently, and then it should be idempotent. So you should also call it from the upgrade path. Does that make sense?
I think so.
So from the main upgrade function, you can import the phases and then call it. The problem with this, though, I was chatting with Tim a little bit. If you scroll up in the SIG cluster lifecycle channel, we have an issue to think about a little bit, because ensure TLS is going to have since it needs to be idempotent, we have to be able to verify whether or not the flags are there or not, because it's a mutator function. So the current static pod upgrade path right now is fully declarative. The self-hosted control plane uses mutator functions on the pod manifests, which is kind of an interesting pattern. And I would just like to hear some consensus on the fact that like we are going to treat like flags as like some kind of API with certain stability constraints. You know, I guess this code only needs to be work for upgrades from 1.x to 1.10, because everything else will be TLS by default in the future. But like we have to think about the lifespan of this ensure TLS phase, because it needs to be able to look at the old pod manifests and be like, oh, there's no TLS implemented in these flags, and then add the flags if it thinks that it should.
So in general, I think this is a problem that we're going to encounter in the future anyway, because one of the things that we're going to have to look out for as kind of kubeadm gets more real world use is that users are going to want to modify kind of the running config as we go along. So assuming that we can just drop a static manifest for some of these things, that assumption is going to go away over time, I think. So at some point, I think we're going to have to look at being able to mutate the static pod configs anyway. Oh, you're muted, Lee.
One interesting point here
Sorry.
is if we are pivoting on the kubeadmin config map for detecting the current status of the cluster, or if we are checking static pod manifest or whatever.
So sorry, Fabrizio, I can't speak for everybody, but you're cutting out, I think.
It was hard to hear you. So I think I got the gist. If my McDonald's drive-through history has proved any value, is that I think what he said was whether or not we are going to rely on the config map when doing the upgrade process, which I think we should. I mean, honestly, I would not. I think anybody doing things out of band is subject to be. You have made your choices. You have made your bed. And everything requires to go through the command line options directly, or to edit the config file manifest and to do some type of reapply or this gets into the other bit that we were talking about, which was reconfig. We don't actually have that as a phase. We have like upgrade and init, but we might want eventually a reconfig, which then, you modify the config itself, and then reconfig would have to check state and rectify anything that's missing if you edited the config. So the config would be the central source of, authority.
If we're going to go that route, do we also want to have kind of a best attempt at a reverse kind of function for that, where we attempt to sync running config to the config map?
No, I see what you're saying. I don't. You mean there'd be like controller rectification, which we might eventually get to. Like we might want to have some style of that in the future. I think having an explicitly called out operator action that denotes like your config is dirty. Would you like to reconfig, or versus having it like an explicit action, because configuration in a cluster almost requires like very explicit action.
Yeah, I'm just thinking because all the existing documentation for how do you modify these components right now would have them going in and manually editing.
Modification should be a rarity, right? For most use cases. Like the whole idea is that it should be so easy that we consider clusters to be ephemeral, because in the ideal world, we don't want to get into the notion of even having clusters as pets. We just want to make it so stupid easy that you can, anybody, you know, it's like Oprah for clusters, right? Just make it so easy that you can stand up a cluster, and to make it easy to snapshot and restore it across clusters, that the idea of trying to maintain cohesiveness across many versions is a recipe for disaster in cluster management. History has taught me that this is a very bad thing. And people treat their clusters like pets, and it becomes this Bondo duct tape ball of soup that no one understands over a period of time, right? So what happens is you go into a place, some initial person stood it up, 2 years later, some new person came on board, they have their own ideas, but then they left halfway through implementing them. Then the third person comes on, they're like, what the hell, got to burn it all to the ground, right? And this happens all the time in configuration management.
Yeah, my biggest concern is making sure that we don't go ahead and apply a breaking change to somebody's cluster during upgrade, because I've been there, done that.
On that line, like kind of on the same concern as what Jason just mentioned, is I think like for a specific mutator function, like ensuring TLS flags on the etcd server and then on the API server, we would want to like have it probably fail critically and warn the user, like if the flags in question to be applied are actually present in the extra args map or something like that.
Yeah, there's going to have to be a check, no doubt. Like, I mean, we're going to have this like weird, until it's the default everywhere, we're going to have this weird mutation thing that we'll have to validate across the release.
Because this is just not something that we have any structure for at the moment. And like it also begs the question of like if we should get rid of a lot of the declarative model entirely and break it up into features specific mutator functions.
I don't know if I'm going to go that far yet. I'd like to see the code and how it changes. To validate what is required in order for us to make this change.
I'm thinking that after we are so in this case, to support this upgrade, the mutator function needs to happen before the static pod declarations are made. So basically, what the mutator function is for is to resolve an incompatibility between the old declaration and the new declaration.
Yep.
And so like we will need this kind of like resolving state if we want to make a minimal change to the code, is I guess what I'm getting at. So we would keep the declarative model, but then we would have these mutator functions that would kind of pre-process the upgrade result beforehand.
Yep.
And they probably are going to have their own restart logic, which is a little strange.
So this is like the last bit of that upgrade scenario that needs to be addressed. So man, this is a thorny one.
Yeah, it is.
So the question that I have is if we can refine kind of the kubelet API and etcd API kind of change set that I have, that would unbreak the TLS upgrade portion of it.
Yeah.
Do we want to not focus specifically on ensure TLS as a phase, but rather work on kind of generic refactoring of the upgrade to be more flexible in that regard for 1.11?
This was the simplest thing that we came up with. And I think that it is the right approach, but it has a bunch of other caveats with the stability and the support and the fact that nobody but the API server uses the kubelet API.
Yeah.
And yeah, did you have anything else to add, Jason? I don't mean to.
Well, I'm just concerned. So are we gonna are we looking at trying to solve this for 1.11 and just removing the TLS upgrade, TLS enablement on the 1.10 upgrades as a stopgap? Because trying to backport this much of a refactor into 1.10 kind of scares me a little bit.
I would agree to that. I think not having consistency across the upgrade path to just make it as simple as possible to unblock folks is totally fine. And again, I want to get out of the notion that we need to treat part of the workflow for doing any type of upgrade should be like snapshot your cluster, right? Before you even do the upgrade. And then if you want to, sandbox it and create a blue-green deployment, right, for you to do your upgrade if you need to get it ready in preparation for the Kobayashi Maru, right? And then do the upgrade. If in 1.11 we can have a more comprehensive approach of how we want to deal with it in the future. That seems like a better long-term sustainable thing.
So yeah, just to kind of highlight some of what Jason's pointing out is basically the whole reason that we have this issue with the etcd TLS upgrade is because we are depending on the API server in order to determine if a component that we are upgrading restarts and is running, which is really kind of gross when you consider that you're updating two components that are necessary for the API server to function. One being etcd, which the API server doesn't work if that's not up, and then two being the API server itself. So this is where like it seemed like the biggest red flag was when Jason and I sat down to talk was we're using the wrong abstraction layer for the API to determine if our processes are even running. Like we should use something else that's not dependent on that like part of the stack.
I think we can also push back on the SIG-Node folks too. If there are pieces that are missing from the kubelet API that we think should be there, we have Signal and we can help drive that forwards if we need to, because it's basically, I don't think there's any owner, I don't think there's anyone who'd be reticent to push back on some enablement of some features for the kubelet API.
Yeah. There's a couple of points here for sure that we could dig into if everyone's kind of at a good baseline for this conversation. But
I think one of the biggest issues that we're hitting against is that we're trying to actually manage etcd for a subset of the installs right now, and that's conflating some of the management that we're doing kubeadm as well.
Sure. Well, I don't think it'll be a problem if the kubelet API was fully formed, right? If you had something you can rely on as, hey, generic static pod manifest starter, do XYZ, right? And give me all of the same checks and guarantees that I get with the API server, which is like probably too much, right? Then it would be totally sufficient for what we needed to do.
This would really simplify kubeadm as well, because there's a lot of code where we've basically written a client, a formal API client for interacting with static pods on the file system, when really that's something that I feel should be vendored from something that's supported and versioned in the kubelet. And we're vendoring the pod spec type and all of that stuff, but then we have to create all of this logic to say, okay, let's put a pod on the file system, treat that as a request, and then validate that the kubelet started it. It's a very strange flow.
Let's, for the purposes of time, because we have other things to go through, let's open up an issue in the kubeadm repo to discuss in detail the kind of an ideal state of where we would like to go to. In the meantime, we still need to bondo a release out, and I like the idea of don't upgrade certs in the upgrade path. Like just get it out there, get it capable and working, and then in 1.11 we'll have to address the upgrade scenario cleanly, right? It also in 1.11 we can push on the kubelet API and figure out how far we can get it, right? So I can have all the right people to talk to. I just need to let them know and have a well-defined problem statement that I can say, hey, we're gonna we're going to try and address this one thing. Do you have PR bandwidth to review it? Yay, nay, right? Does that seem like a reasonable approach?
That does seem reasonable. It's probably the easiest thing to do is fix the race condition and then rip out TLS support altogether.
Well, we're talking about ripping out the TLS for just the upgrade, though, right?
Just upgrades, yes.
Yep.
Keep in mind that this now pigeonholes us to making the TLS upgrade work from both 1.9 to 1.10 and 1.10 to 1.11.
Well, the TLS upgrade, which doesn't work from 1.9 to 1.10, we're explicitly saying, hands up, we don't care. Then in 1.10 to 1.11, we are saying, yes, we have to address this.
I suppose so, yeah.
But that means for the 1.10 to 1.11 upgrade, we need to be able to handle both unsecure and secure etcd as part of the upgrade.
That's what I was saying, yeah.
Yes. But that gives us time, right, to address it.
Yep.
And it makes me feel icky because we're splitting up the feature. But so this doesn't affect our current timeline for kubeadm GA.
We do not have a formal timeline for kubeadm GA. We are dependent upon other features of the system being promoted in order for us to actually get to GA status. The one work item that was on our plate specifically was, security. So that bit, as long as we check those boxes, and when we check those boxes, I think we can get most of it done in 1.11, right? As what we're just talking about. So that seems reasonable. The other ones are going to be totally dependent on, getting dynamic cluster config enabled. We already have the PRs to enable it. It's not hard. We just need to have the feature promoted to beta so we can rely upon it.
And then just to be clear, to reduce the amount of work that we need to do in response to this issue and to prevent any further complexity in the upgrade process, I think it sounds like we're going to veto a ensure TLS pod mutator phase.
For the 1.9 to 1.10, yes.
For 1.10, yeah. And whether or not we do that in 1.11 is a different design decision, but it doesn't sound like it would be required.
I would like to put in a requirement for 1.10 to 1.11.
From 1.10 to 1.11 have a phase specifically for that?
Potentially, we need to figure out the details, right? I want to see the code. I want to see what it would look like.
Okay, cool.
All right. We have a bunch of other stuff to go on to real quick too. I'll take a pause here and then we can go back to the config file changes. Cole, you said you wanted to intro something?
Is Liz on the call and is she gonna talk about the config map plan? Because this is the only thing that we have to talk about for the upgrade.
Yeah, I just wanted to get a pause real quick so we're not just rabbit holing on this one issue.
Okay,
and
cool.
Then go back to it.
Cool.
Can you actually hear me right now?
Yes, we can.
Okay, Zoom's being a little weird. So I just want to say hey real quick. I'm going to start attending the SIG Cluster Lifecycle meetings and these kubeadm meetings. I got a heads up that self-hosting was changing a bit. I'm one of the maintainers on BootCube, so I'm interested in how we self-host and how that contrasts with how kubeadm self-hosts. And I'm going to kind of be taking two angles on kind of trying to push BootCube forward. One is prototyping BootCube, where instead of using self-hosted secrets, we actually bind mount in the secrets from the host, and we try to use the built-in kubelet checkpointer. And then I'm also going to be taking a look at restarting our efforts to possibly add some sort of secret checkpointing into kubelet. Whether or not kubeadm would ever use that is potentially a separate question. But anyway, that's kind of context for why I'm showing up, and I'll be paying very close attention to your comments, Tim, on how kubeadm is changing how they're doing self-hosting.
Okay, cool. Liz, do you want to go? We'll talk about self-hosting a little bit too. I just want to make sure we get through. I want to give pause for other folks to chat about stuff too, because it's meant to be a cohesive thing, not just me monologuing about issues. Liz, do you want to give the TLDR for other folks who may have not been caught up on the config file problem and kind of the exit strategy, as well as possibility that we're going to have to create a KEP for long-term beta support.
Yeah, so can you all hear me okay? So the basic issue is that we rely in the kubeadm master config, we rely on a bunch of other structs, and those structs are also alpha, and one of them changed from underneath us in a way that was not backwards compatible. So what that means is that the configuration serialized by kubeadm init on 1.9 does not deserialize in 1.10. The stopgap solution that we came up with is we take the YAML, we deserialize it into just a map, mutate it such that it is compatible with the new schema for the configuration struct, and then we serialize it back to JSON and have it decoded in the normal API machinery fashion. There's a PR in progress for it. I've gotten a lot of really good comments on it. Hopefully that can get merged in the next couple days. It will need to be backported to 1.10. But other than that, we should pretty much be good to go on that front.
Backports are simple. It's just a cherry pick modification. The tooling does it for us, as long as there's no conflicts.
Yeah. Fabrizio made a very good point about the strategy that we're using right now of just sort of blindly applying this update is not going to work forever. We need to come up with a sort of more formal, rigorous way of applying these updates. I suspect that this sort of thing is going to happen again. I think we didn't notice it this time because of some of the upgrade test bugs that Jason was talking about. But even if we had noticed it, this probably is going to happen again. And so far, the best option that we have right now is properly versioning the API and using the conversion logic between the internal API representation and the external API representation that we're doing as part of the upgrade configuration check phase. So I think that's the long-term solution. The only problem is that there's not much point in moving our configuration map to beta if we're relying on underlying structs that are themselves in alpha. So either we're going to have to make our own copies of those structs until they reach beta, or we're going to have to block this particular change until those structs reach beta. I haven't made a comprehensive list of all of our dependencies yet. I'm planning to do that soon as part of this work. But neither of those options are great, but we're probably going to have to pick one of them.
Okay. Could you create a KEP for this one? This is definitely KEP worthy to have a long-term strategy. Depending upon what the structs are and where they are, and knowing the entanglements, because I have not dug in to know the details of what pieces of the puzzle are alpha and what are not. It depends upon whether or not we want to have an extra layer of indirection to be able to support these things. I think this all goes into a proposal, I guess. There's no way for me to really hot take on it without seeing the details.
Yeah, I can absolutely do that. Yeah, the feature flag structly is part of the kube proxy configuration.
That's really peculiar to me. But interesting.
Yeah, I mean, you can see how people arrive at this. They see this like giant 20, 30 plus field struct, and they're like, I really want to copy all of this. wholesale. And even if we had done so, even if we'd made our own internal representation, this migration logic would still have to live somewhere for us interfacing with the system that needed the kube proxy struct. So this is just one of those things. I've been thinking about it in terms of database migrations, like a series of transforms that you apply one by one. But that may not be the most sensible way to think about this, but this is all going to go into the KEP that I'm going to write, because this is going to happen again. And
this makes me actually wonder if we should make it a rule not to use underlying APIs that are not yet beta for this type of use.
Well, I mean, we're going to, that's probably going to be part of the KEP. Like, I think there's you can't, if you're a beta API, if you're a beta struct, you shouldn't be able to depend on alpha structs. I don't know if that's a rule right now, but it certainly should be.
It is. It is. Things should not have gotten in. There should have been, it depends upon what features were propagated through, and again, we'll wait for the KEP to go on it. I don't think we should bike shed too much on this without the details.
Yeah, I think the KEP is going to be the place for us to bike shed. I think it should be blue.
Sorry. I have a concern about the fix that is going on, because now kubeadm supports using the 1.10 release support to upgrade a cluster from 1.9x to 1.9 epsilon. And what I'm concerned is the following part. If we read the config map, we fix the format of the feature gate flag, and then what happens if when we save the proxy config map for making the kube proxy use it? I think that we get an error. So,
well, we we aren't going to backport the fix to future 1.9 branches. So,
but what are you backporting? Are you changing the type in the kube proxy?
The type has already changed.
Yes, but it is changing in the 1.net version of kube proxy.
We're not changing anything in any of the 1.9 releases.
I think Fabrizio's concern is that you can upgrade with the 1.10 release of kubeadm, or 1.10.x, is that you can do a minor upgrade for 1.9 to 1.9x. Is that what you're trying to state, Fabrizio?
Yes, and in this case, I will have a 1.9 kube proxy, but I will pass to this kube proxy a config map with the 1.10 format.
I didn't know you could do that. You can use a 1.10 binary to upgrade to a 1.9 release.
Yeah, it's the target version output. That was one of the features that's there. So, I mean, you can easily modify the PR. Why don't we address this on the PR itself and talk about it there?
Yeah, but, sorry, Fabrizio. I totally did not realize that was a. I did not realize that was how this worked. I can definitely address that.
Yes, and it is a really tricky problem. We chatted a little bit in Slack today with Jason, and after thinking a little bit about this, my idea is that we have to, for this cycle, due to this not backward compatible change, we have to forbid to use 1.10 to upgrade from 1.9 to 1.9 something.
I can also just gate running this particular transform unless the target is at least 1.10. I think I should be able to make that work.
Yeah, I think that makes sense. We can probably move on from this and cover it in the PR if everyone's cool.
Yep, I agree.
Plus one.
I wanted to quick go through the self-hosting bit because Cole talked about it really quickly. I'm going to open up an issue with regards to this in the kubeadm repository. But for a long time, we have gone full circle inspecting our own belly buttons, trying to understand the state space of self-hosting upgrades and high availability. And at some point in time, you need the ability to bootstrap yourself and to be able to restart during the two edge conditions that matter the most, which are basically single master control plane going down, and the second one, which is the whole DC outage in an HA control plane environment. You need to be able to recover from those failure conditions. And with self-hosting, the problem is you need an initial seed either on the kubelet side to restart the API server, otherwise it doesn't know where it is. So instead of us trying to add checkpoints all over the place, and this kind of proliferates into like checkpointing config maps and all the details of what comes around secrets and whether or not you want to checkpoint secrets in a self-hosted environment, was to say punt on all of it and go with the simplest solution possible, which is you only need a single API server. The part of the bootstrapping process itself is you have a static manifest and then you pivot, right? And if you had a pod that just wraps that behavior on startup and basically says check via kubelet API, am I running? Yes, no, right? And if I'm already running, then don't start something. If I'm not running, then start something. It just continually checks in a loop, right? Which basically will seed a static manifest API server. For its only purpose in life is to basically allow everything else to come back up. And then once it recognizes that this host has another API server trying to execute on it, just kills that static manifest. So you basically have a pod who's a sentinel living as a static manifest, determining whether or not from the kubelet API, if it should spawn itself or not. And by doing that, and just by using host mounts for secrets and simplifying the problem, it just eliminates a whole class of issues that we've had, right? It's the simplest way to address this thing and to get your control plane back up.
Quick question then. So one of the attractive things about the self-hosted control plane is that you can update the pod specs and have the update propagate out with, like no downtime.
Yep.
I'm curious if you would need something to synchronize those updates with the Sentinel pod so that it would be able to like do that.
Yeah, I mean, there's a couple of clever ways I've thought about doing this. We could deal with it. What I plan on doing is opening an issue, creating a CAP, talk about it in the CAP, which is the proper way to do this instead of going through all the logistics, in our heads. But you could either do the transformation, inverse transformation of being able to say, this version of it, I don't even care as long as it has the secrets to restart and get access to etcd, or you could basically do the reverse transform to say, like, talk to the kubelet API and take the modification of what it was to be a self-hosted one, flip it to be a static one, the same transformation, the inverse transformation of what we do inside of the code right now. And then, if you want to, you could say that to var lib whatever as a, this is the manifest that I would use to rejigger myself, right?
So the Sentinels would continue running, but they wouldn't run the API server while the normal control plane is up, while the self-hosted one is up.
Yeah, the Sentinel just sits there and checks to see if the control plane is live.
So the Sentinel's like job while everything is live could be to make sure to write the config to disk or something.
Yeah, the Sentinel's exactly. Yeah.
Okay.
So it basically validates the version that it has on disk is sane and is the correct version by inverse transforming from a self-hosted to a static manifest, which is pretty simple to do. You gut out a couple of key fields.
So in the cluster DC outage, what keeps the self-hosted, or what keeps the Bootstrap API server from starting up on every single node?
It would start up on every single node, and it would kill itself afterwards. So the only purpose of that would be to get the other API server online, and then it would flip.
Right, I understand. But 200 nodes or whatever are going to come up and connect to, like, all those API servers are going to come up at the same time and try to connect to etcd, and then they're all going to try to, like, where does the scheduler get brought back up?
The scheduler gets brought back up because on a self-hosted environment, all you need is the API server, and the kubelet, because they're self-hosted by the kubelet can rectify the state. So as long as the kubelet, this is one of the fun conversations we had a long time ago. The kubelet, as long as it can talk to the API server, can get the bound pod manifests that are for that machine, and the masters are pre-configured, so they'll have, they're part of daemon sets, so they'll be there. So they'll be bound to that host. So when they come back online, they will basically say, I can talk to the API server, get my bound pods, run and execute the scheduler and controller manager, right?
Okay.
Does that make sense? And this will only cycle on the master nodes. It will never affect all of the other.
Okay.
In the system would not be totally unaffected. It only affects the master nodes.
And how is that property enforced? That's because the daemon sets had only been scheduled on those master nodes, or you're passing an extra flag to kubelet, or what's the mechanism by which they?
Daemon sets are only been scheduled via taint restriction.
Okay, and so when kubelet comes back, so I guess what I'm not quite getting quite yet is how the daemon set is bootstrapped onto the master nodes then.
It's the initial kubeadm init.
Okay.
kubeadm init will do the initial deployment of the initial control plane, then it does the pivot to self-hosted, right? And the initial deployment, then pivot has everything up and running before it exits.
Right. So on cluster on DC crash, when everything comes back up, those masters had the API server assigned to them. So whenever they bootstrap themselves back with an API server, they'll get their own API server pods back, and then they'll be able to pivot. Okay, I got it. Thanks.
Does this config support reclassification of the nodes?
What are you talking about?
To take a worker node and then turn it into a control plane node?
I don't know where you're going with that, but usually they're very, when you set it up the way kubeadm works, you're going to have to do a join master. And I don't know, Fabrizio, I don't even really want to entertain the idea of changing a node from a worker to a master. The idea of immutability would say, like, you have dedicated these nodes for these things. And I think sticking to the immutability constraint allows us to be very, put blinders on and not care.
Yeah, I'm just thinking about I guess you would do the master join workflow for new nodes, and then you would have to purge them if you wanted to scale it down.
Yes.
So you wouldn't be able to just simply use an ASG without some other kind of synchronization. But cool. I think I'm following.
Okay, I need to write up a KEP for that one, but I was looking at the history and the backlog of this stuff, and I was also talking with some other people who wanted to do full checkpointed support, which is bananas, yo. But it's a tough problem to solve. It's really tough.
And then, sorry, I think the last gap in my understanding here is the daemon set schedules static pods to the kubelet, or the daemon set is expected to just run when the nodes restart?
The daemon set schedules pods. Those pods are bound to the master nodes, right? And that's as part of the initial kubeadm init for the control plane. And the init will also have the sentinel as a static manifest, right?
Okay, yeah. So that's the part, I guess, is the sentinel is the main thing for a master node, and that is a kubeadm operation.
Yes, it'd be part of the pivot. So right now the pivot lays down the initial control plane. Then part of the pivot to be a self-hosted would be to schedule the new API servers and lay down the sentinel, right? And remove the other static manifests.
Do you take into account the change that is happening for demo sets? They are changing them to be scheduled via the scheduler.
So they shouldn't matter so long as the pods are still bound to the host. What will happen is the scheduler and controller manager will be brought up online and eventual consistency will be reached. Those nodes should come back online so long as the kubelet can talk to the API server, because the pods are bound and they've already been scheduled, right? The daemon set doesn't need to reschedule itself. They've already been scheduled the first time when the control plane is laid down.
So the scheduler would be, in the case of a reboot, the scheduler would start as a static pod from scratch, right?
No, it would start as a bound pod. It still was originally a daemon set when it was deployed. It's been bound to that host already, right? So it doesn't need to be rescheduled. It's bound. You just basically say the only thing it needs is that the API server needs to come online first. So the kubelet, when it checks in with the API server, it says, "What are my bound pods? Oh, I have a scheduler and controller manager. I start those bound pods."
Oh yeah, makes sense. Thanks.
Yeah, it's a little bit of navel gazing, but it's a lot simpler.
Could this be something even simpler, like potentially taking the bound pods and just shipping them to the kubelet API if we had like a stable kubelet API?
Well, that's what the checkpointing kind of does, right? Like but the problem with that is you proliferate resource objects, right? And then you get into this weird state space of like, what happens if I want to checkpoint secrets to disk? And
Yeah.
what happens if I want to start checkpointing config maps to disk?
Because then you have to pivot from the checkpoint back into the API server representation in etcd. So that's
exactly.
Okay. Yeah, I agree with this. This sounds a little simpler. So
a lot simpler in my mind because I've been fully down the rabbit hole. So
we're finally at a point years down the road where we can start up a node and have Kubernetes restart.
But it survives HA, single or even multi-node failures. But anyways, I think we're kind of running out of time. I did want to have Fabrizio have a quick update, if you had any, to talk about the state of any HA modifications for the master join scenario. Can you talk now, Fabrizio, or are you still in a loud, noisy environment?
No, I can talk, but I miss.
Okay. Fabrizio, do you want to discuss the current master join status?
Okay, the status of the current master join, this is what are you asking?
Yes.
Okay, so we had a quick talk last week, and what I'm doing, I'm breaking down the prototype in a set of small PR. What will be implemented will be a little bit different from the original PR because now there is the control plane address flag, and we are using this flag to give a stable IP address that is the load balancer address. And so the result will be a little bit more difficult, but a little bit different. But at the end, it opens up some interesting scenarios, like supporting the cluster where we have different advertised address. But we will address these while going on with the single PRs.
Okay.
I'm sending a checklist issue as soon as possible.
Okay, that will help a lot. I'd almost even request to send a checklist issue for how we want to deal with phases. I looked through the PR and I'm going to re-look through it again later on because all I'm doing today is looking through issues and breaking down the backlog. But there a lot more thought needs to be. I need to think about phases a lot more and how we're going to promote that stuff. And I think other folks do too. because I want to be careful in this release cycle. We have a lot of stuff going on, which is good. But at the same time, I want to make sure we bound the scope of all of the changes to be a set that is consumable and doesn't cause too much churn within a given release cycle, if that's a fair statement.
I totally agree. Because
Okay.
with the change of phases, we are changing the init workflow. So we are touching that it is a change that we have to do really at the beginning of one cycle.
Yep. But I will come out on the PR and take a look in more detail and try to come up with a cohesive set of ideas there. Maybe we can talk about it next week. Does that seem reasonable?
This is reasonable for me. And the major other question is about the approach. It is a question raised by Ilya.
Mm-hmm.
And I commented this in Slack. It's like 10 minutes before the meeting. So you can find the reference of the comment.
Okay. We have reached time and I see other people joining right now. So I want to make sure I jump off here. So give Chris a chance to deal with the cluster API stuff. So thanks everybody. And we'll chat next week.